is probably covered in chapter 2 for most of the books. And basically, it just deals with force addition. You have two different vectors or forces. For vector is kind of a representation in this case of forces. Uh, and then we have to find the resultant force. There are several ways that you can do this, but I want to use for this one the law of sines and cosines in this particular problem. So basically what you have to do is complete a parallelogram here. I'm just going to draw a parallel line to this one and a parallel line to this one, this other force here. And whenever you are doing that, you complete the parallelogram, and the resultant force graphically should be this one from here to here. That will be the resultant force that we are looking for. And of course, the angle, it says measure counterclockwise from the positive x direction. It shouldn't say that because it's implied. Every time that you mention direction is positive counterclockwise from the x-axis. So this is basically the direction that we are looking for this problem. Now, how to do this problem using the law of sine and the law of cosine? Well, we have two very distinct triangles. We have one triangle here and one triangle here, which are basically a mirror image, one of the other one. And then we can start drawing angles here, the angles that we have in those triangles. We have this angle. This is 45 from here to here. And this little wedge, I'm going to call it alpha. So that angle over there will be 45 plus alpha. Now in the other side, I can calculate this angle, which is the same as this one here. That's why you have that triangle over there. Sorry. And then I can calculate that complete angle. I can say that the tangent of the angle will be 12 divided by 5, or that angle, I don't know, let's call it beta, is inverse tangent of 12 divided by 5. 12 divided by 5. That means that that angle will be 12. Where are you? Where are you? Where are you? Here. This is 12 divided by 5. Inverse tangent. That angle is 67.38 degrees. However, the angle for the triangle, yes, this is correct. This is beta, but the angle for the triangle will be just this portion, this from here to here. So it will be 67.38 minus alpha. And if you look closely, that angle is this angle as well. So that angle over there, from here to here, will be 67.38 minus alpha. Now we can draw that triangle if you want to, separate, just to simplify the drawing that we have here. So let's try to do that here. I have this one here is 260. This one here is, I'm gonna do this triangle. So then this part from here to here, which is that one, will be 260. And now this other side, which is this one, will be 310. And the resultant force will be this one. I'm gonna put it here, resultant force. I don't know how much is that. And then we can start placing the values that we have here. So this angle here will be 45 plus alpha. And this angle here will be 67.38 minus alpha. This angle I don't know, but if you remember the triangle properties, if I add the three internal angles of a triangle, that has to be 180. So then I can calculate this angle here, and I don't know, name it phi, phi. So then phi will be 180 minus this angle minus this other angle. Which basically this alpha minus times minus is plus, and minus times plus is minus, is going to cancel, and phi is going to be 180 minus 67 minus 45, and that value will be 180 minus the previous value, which I have here already, minus 45. That will be 67.62. 67.62 degrees. That will be this angle here. And this is the resultant force. Now with this triangle, we can apply the law of cosines. Remember the law of cosines, basically what it is, or what it says is that if you have two sides, A, B, and then you have the third side here, C, and you have this angle between A and B, I don't know, you call it theta. Then basically what the law of cosine says is C squared is equal to A squared plus B squared minus 2 times A times B cosine of that angle between A and B. Meaning that if you know this side, you know this side, and you know this angle, we can calculate the resultant force in this case. And I can take square root both sides, and this cancel. So basically I have that the third side, which is this one, is going to be the square root of this. And I'm going to do that. The third side is the resultant force in this case, is the square root of 310 squared plus 260 squared minus 2 times 310 times 260 times cosine of this angle. And this angle we just determined it to be 67.62. Perfect. So the resultant force, when we calculate that, you can put it in the calculator. I like to do it by parts. I like to take the square root at the end, but you do it in any way that you want to. So 310 squared plus 260 squared minus 2 times 260 times 310 times cosine of 67.62. That's going to give you this. Square root of that is the same as elevated to the 0.5. So you get 319.88 pounds. And that's part of the question. It was the resultant force. This is the value of the resultant force. Now for the orientation, I need to know the value of alpha, because basically the orientation will be this one. That means it's going to be 180 minus that little wedge, as I said before. How do you do that? Well, we apply here again what we have. But now we're going to use the law of sines. And the law of sines, basically what it says is, if you have a triangle, any type of triangle, and you say this side is, I don't know, A, this side is B, and this side is C, and you call this angle A the opposite, angle B, and angle C here, you can say that the sine of C divided by big C has to be equal to the sine of A divided by big A, and it has to be equal to the sine of B divided by B. Now we do that. Look, we have this side, which is the resultant force, and we have this angle that we calculated before. So I can say sine of that one divided by the opposite, the sine of this angle divided by the opposite side, 319.88, has to be equal to either the sine of this divided by that, or the sine of this divided by that. I'm going to use this one. The sine of 45 plus alpha divided by 260. Now from here, I just pass this to this side, and I can do that. So, oh, I have this here, which is awesome. So I'm gonna take 260 divided by that value, multiplied by the sine of 67.62, and then I'm going to get this value. That value will be the sine of 45 plus alpha. I take the inverse sine of that, and then I get 48.73, meaning that 48.73 is going to be equal to 45 plus alpha, and alpha is going to be equal to 48.73 minus that, meaning alpha is 3.73. Why alpha? Alpha is just an intermediate step. Remember, this is alpha, but we need the direction from here to there, and we know that the x-axis here is 180 minus alpha. 180 minus alpha will give you the angle that we are looking for here, and that will be basically 176.27 degrees. That will be the direction. What is the answer for this problem? Resultant force and direction measured counterclockwise from the positive x-axis. I hope you like the problem, guys. I'm going to solve the same problem in the next video, but I'm going to be using force decomposition. That's it, which in my mind is easier and makes more sense from the engineering point of view, but this is another way that you can use. And sometimes it's faster doing it in this way, but it's up to you to decide when to use each one. See you next video, guys.